Relations and functions. A function is a special type of relation, and these relations will be expressed in many different pictures and graphs and tables. So the first one we're going to look at is when they're listed in these oval shapes. And the first oval shape, that represents your x values, and the second oval shape represents the y values. And over here we have three questions we need to answer. We have to state, is this a function? So yes or no. List the domain and list the range. And as a review, the domain, that is all of my x values, and the range is all of my y values. So first I'm going to see, is this a function? That means, does the x value repeat? So if the x value repeats, it is not a function. And that's how we can tell when we have a list of numbers. So let's look at our x values. I have -3, 1, and 4. -3 has 1 arrow, 1 has 2 arrows, and 4 has 2 arrows. So that means 1 and 4 both repeat. So since I have repeating x values, we would say no, this is not a function. Now domain and range, there are going to be many different ways that we have to write this down, and you've got to be able to tell the difference between them all. Here we just have a list of numbers, so that's all we have to do. We're going to go squiggly line, and we're just going to list our x values. We're going to say -3, comma 1, comma 4. So those are my x values. I'm going to end it with another squiggly line. Same with range. Because it's just a table, it's a list of numbers, we just list them out. So I have 3, -2, 1, and 4. Now, notice in the domain, even though 1 and 4 both have 2 arrows, I only list them once. And that's true. We're just going to list them once. If you were to list them more than once, you would be wrong. So that's it. That's our first example of a relation. We will also see points graphed on a coordinate plane. And so first, let's ask ourselves, is this a function? And since these are just random points, they're not connected, I can check, does my x value repeat? Or we can use the vertical line test. Hopefully that sounds familiar. So I'm going to take my vertical line and I'm going to go through each point and see, does the vertical line only hit once? So here we hit once, only one purple dot, hits only one purple dot, hits only one, it's only one, hits only one. All right, so my vertical line hit only once. So that means, yes, this is a function. It passed the vertical line test. So that means whenever we have a graph, we can use the vertical line test to tell, is this a function or is it not? And then domain and range are next. Remember, domain are my x values, range are my y values. So let's look at my x values first. These are random points, so we just have to list them again. So I'm going to go squiggly line, my x value of -4, comma, -2, and then I have -1, 1, 2, and 4. So there's my domain. Just all of my x values. In my range, I'm listing my y values. So I have 0, then I have -1, +2, +1. This should be -5 because it's in the negative quadrant. That was a typo. And 0. And that's my range. All right, let's go on to the next one. So now we have something a little bit different. It's not a list of numbers and they aren't random points. It is a graph. And since it is a graph, we still get to use our vertical line test to see, is this a function? All right, so I'm going to take this vertical line and I'm going to go through the whole graph. So does this green vertical line only touch my red graph once each time? Yep, looks like this side it's only touching my green line once as I move through. And on the other side it's only touching once. So it does pass the vertical line test. So we would say yes, this is a function. Now domain and range, this is where things get a little bit different and a little bit more complicated because we have these arrows on the end of our graph. And that means this graph is going to continue forever. And the symbol we use forever is called infinity. And you can have a positive infinity, which means it's going to continually go towards the positive numbers forever. And you can have negative infinity, which is going towards the negative numbers forever. All right, so let's first look at domain. And remember, domain are my x values. And if I were to label some of these x value numbers, right, I would have 1, 2, 3, 4, 5, and we could keep going. This is 10. This doesn't stop. If I kept going, it would be 11, 12, 13, 14, 15. So if I kept going over to the right, I would eventually get positive infinity. And the infinity symbol, I'm going to do it up here in purple. It's kind of like a sideways 8. So this is positive infinity. And then negative infinity would just have a negative sign. So negative sideways 8, that is negative infinity. All right, so again, domain, let me get my highlighter. Domain is working with our x values, and our x values always go left to right. I'm just waiting for the highlighter to load up here. All right, so domain, I'm going to actually highlight in yellow. It's our x-axis. So it's asking how far left and how far right does this graph go? Well, these arrows mean it's going to keep going to the left and it's going to keep going to the right. So since it's going to keep going to the left forever, that means it's going to go, I'm labeling my negative infinity to the left because all of my negative numbers. So that means this graph is going to go to negative infinity and to positive infinity. So that's how I'm going to write my domain. I'm going to say negative infinity, comma, positive infinity. You have to write it this way. The negative number, the smaller number, always goes first. So what this is telling us is that this red graph is going to always go to the left and it's going to always go to the right because of those arrows. Now the last step before we're done with domain is we need to close this off. And we're going to put parentheses on negative infinity and positive infinity because you can never actually touch infinity. It's a concept, it's not a real number. All right, then let's talk about range. Now range, they are our y values. So we're looking at our y-axis, which is up and down. And let me do this. My highlighter isn't working, so I'm going to make the range this blue axis. So the range is asking how far up and how far down does this graph go? Well, my red graph stops right here. And the y value that's 0. So the farthest down this red graph is ever going to go is 0. So that's my smallest number. And then comma, I've got to list what's the highest number this graph is going to go to. So looking at my red graph, again, I have these arrows on the top of them, which means it's going to go up. It's going to go positive forever. So I'm going to use positive infinity. And then to close this one off, it's a little bit different than domain. 0 is an actual number, so it gets a bracket. It's a hard parenthesis. Infinity isn't a real number. You cannot touch it, so it gets a parenthesis. I know that was probably a little confusing, so again, make sure if this is going too fast or if you're getting confused, pause the video so you can go back, maybe re-watch it, or you can always come and see me or email me with any questions. We do have a few more examples, so hang in there. All right, so back to a table now. So here we just have to see, does my x value repeat? So I have 0, 1, -2, 3, 1. Uh-oh, I've got a repeater. So since my x value repeats, we would say, no, this is not a function. And again, since this is just listing numbers, that's all I have to do with my domain, which are my x values, and my range. All right, so squiggly line, because we're just listing, we're going to say 0, comma, 1, comma, -2, comma, 3, and close it. We're not going to repeat the 1. If you repeat the 1, you would be wrong. Same with the range, we're just going to list. So squiggly line for our list, 1, -1, 0, 2. Again, we're not going to write 0 twice. We're just going to list the numbers once. And then close with the squiggly line. Squiggly line is when we list. All right, and we got one more. So it's back to a graph. So back to a graph means, I'm going to pick a different color this time, we're going to use our vertical line test. Okay, so now I've got to take my pink line, I'm going to go through my green circle. So does the pink line touch more than once? Yes, it does. So since my pink line touches more than once, we failed the vertical line test. So that means no, this is not a function. Okay, domain and range, this is when we have to either use our parentheses or our brackets, and we possibly may use negative infinity or positive infinity. All right, so again, domain, my x values. I'm moving left and right on my x-axis. So how far to the left does this go? Well, it stops right here, and that is at -1, 2, 3, 4, 5. So the smallest x value this graph will touch is -5, comma, what's the farthest right? So what's the biggest x value that this graph will touch? 1, 2, 3, 4, +5. Now, -5 and +5 are actual numbers. The graph is touching them. So that means both get the bracket. And then lastly, we have range, which are y values. So we're talking about up and down. So how far down does this graph go? So let's count -1, -2, -3, -4, -5. So the smallest y value this graph will have is -5, comma, the highest value, +1, 2, 3, 4, +5. And again, both are numbers that the graph is touching, so they get brackets. So I know domain and range can be a little confusing, especially when to use parentheses and brackets or when to just list. A couple things just to remind you that when you're dealing with a graph, something where the line is actually connected, we're going to be dealing with our parentheses, brackets, and infinities. When it's just a list of numbers, like in the previous example, which I'll go back to. When it's just a list of numbers, that's when we get to use our squiggly lines, and we can just list it out. So table, list of numbers, use our squiggly lines. If it is a graph with a connected line, that's when we're going to be using infinities, parentheses, and brackets. So again, if you struggled or if you had some trouble with this, feel free to email me or come see me at Bulldog Block for some extra help. I'll be glad to explain it to you.